Hey there, Prof. Aram here, and in this video we're going to cover one of the very popular project valuation techniques that's called payback period. So let's get to it. So what is payback period? It answers a very simple question. How long does it take to get the initial cost back in nominal sense? In other words, how long does it take for the project to break even? How do we do this? We first estimate the cash flows of the project, and then we're going to subtract future cash flows from the initial cost until the initial investment is recouped. For example, if a project cost $50,000 today and it will provide $20,000 in year one and $30,000 in year two, then the payback period for this project is exactly 2 years. It takes 2 years for this project to break even. So the decision rule here is to accept the project if the payback period is shorter or less than some preset limit. Like we call this preset limit the management number. So it is a result of several years of experience by the management. For example, when they look at a project, they have some idea of the number of years it takes for that project to break even or to pay back. So it's a very arbitrary and subjective number, but usually works. How do we calculate the payback period? It's very simple. First of all, let's assume that the management has a requirement that the projects should pay back in 2 years. We're going to look at the same series of cash flows that we had before. So it will cost the company $165,000 today. Year one's cash flow is $63,120. Year two cash flows are $70,800. And year three, we have $91,080. How do we do this? First of all, we're going to subtract the future cash flows from the cost until we get to zero, until we get to a break-even point. So in the first year, we have $165,000 cost minus $63,120. This will give you $101,880. You haven't recovered all the costs yet, so we'll keep going. We have $101,880 minus $70,800. Your leftover is $31,080. This leftover is less than the cash flow in year three. That means that we don't need all the year three cash flows. We just need a portion of that. So how much do we need of this third year cash flow? That would be the fraction of the remainder, $31,080 over 9180. That gives you 0.34. So your payback period would be 2 years plus 0.34 years. So 2 plus 34. So you end up with 2.34 years. Should we accept or reject this project? Based on the management number, the cutoff point provided by the management, we should reject this project because it pays back longer than what the requirement is by the firm or by the management. Let's see how do we do this in the financial calculator. You can basically do this math in the financial calculator. You do 165,000 minus 63,120 minus the second year cash flow 70,800. And since the remainder is less than the third year's cash flow, 91,080, we just divide it by 91,080 to get that fraction, that 30.34 years. But for those of you with a professional calculator, there's actually a function for that. We already entered the cash flows of the project in the cash flow function. And after that, you go to the NPV function. And you go down, down, down. And PB is your payback period. You can just calculate it there. But this function is only available in the professional BA2 Plus. Okay, let's look at it in the Excel spreadsheet. The same cash flow that we had before. Here, we're going to do it a little bit differently. We are going to add the cost So we haven't recovered the whole thing yet. So we do one more remainder plus the next year's cash flow. And since we don't need all of the remainder, all we need to do is just have 2 years plus the absolute value of the ratio of the remainder over the third year cash flow. Or you can just simply do the subtraction and calculate it. I find it easier to do it in the calculator than in Excel, but that's your choice. You can use either one. So now that we know how to calculate the payback period, let's look at some of the advantages and disadvantages of this method. Here we have some examples of different projects, and we're going to calculate their payback period. So project A pays back in 100 minus 30, 70, 70 minus 40 is 30. And we don't need all of this, so 30 over 50 is 0.6. So the project's payback period is 2.6 years here. For the next one, we have 200 minus 40, which is 160, and then 160 minus 20, which is 140, and then 140 minus 10, which is 150. So what happens here? The project does not pay back, so the payback is not available here. The future cash flows of the project in B are not enough to recover the cost of the project. So that's why we're not going to end up with a payback period here. So the project does not pay back. In the next one, in C, the payback period is 200 minus 40, which is 160, and then 160 minus 20, which is 140, 140 minus 10, which is 130, and then 130 minus 130 is 0. So this project pays back in exactly 4 years. What about this one? This is an interesting one. This is an example of non-traditional or unconventional cash flows. So you have a cash outflow today, some cash inflows, and then another cash outflow, and then some inflows. So if you want to calculate the payback period here, what would you say the payback period is? You can say it's 2 years or 4 years. I mean, it can be either one. But just by looking at the cash flows, you can say that the payback period is 2 years. and ignore the rest of the cash flows. Here's another one that is interesting. Of course, some of these examples are not realistic, but it's good to look at them just to find the advantages and disadvantages of this method. Here we have a project that costs $50, returns $100 in year one, and then has a cost or outflow of $50 million in year two. So in terms of the payback period, since the cost is less than the cash flow one, so you just do 50 over 100. So the payback period is 6 months, half a year. But again, we're ignoring this last cash flow. Now let's look at two different projects here. We have one project that has a long-term view, and then the other one has a short-term view. In this one, the payback period would be 250 minus 100, which is 150. So we don't need the rest of, all of the second year's cash flow. So 150 over 200 would be 0.75. The project will pay back in 1.75 years, the short project, and the long one is paying back in 2.5 years. This method is biased towards short-term projects. Since both of them have the same cost, if you're the manager who's using the payback period, you're going to choose the one that pays back faster, short-term project. If you're solely focusing on the payback period as the method of analysis. So let's look at some of the advantages of the payback. It's easy to understand. It adjusts for the uncertainty by ignoring the later cash flows. As soon as you reach the cutoff point, you're just going to ignore the rest of the cash flows. Somehow, it's going to account for the uncertainty of the future cash flows. And then it is biased towards liquidity, which is not a bad thing. So the faster the project pays back, it is better. And on the other hand, some of the disadvantages are very stark. The main disadvantage is that it ignores time value of money. You're just using the nominal cash flows of the project instead of using the present value of the future cash flows of the project. Another one is that it's very subjective. It is based on an arbitrary cutoff point introduced by the management of the company. It means that a project can be accepted in one setting and rejected in another setting, simply because two managers with two different cutoff points are looking at these same projects. So it's very arbitrary, and it's based on the management's number. And it also fails to consider the risk differences between different projects because it is calculated exactly the same for both the risky and the safe project and uses the same cutoff point for both of them. It ignores the risk. And it's biased against long-term projects such as research and development and new products. So let's just call it products. So if you're looking at a project that is lengthy, you shouldn't use payback period as your primary decision criteria. Another important thing is this payback period asks the wrong question. What is the right question? Does this project add value to the shareholders of the company? But the payback period's question is, how long does it take for us to recover the cost of this project? Looking at the questions that we need to answer for each decision rule, does it consider all the cash flows? No, it ignores the cash flows as soon as you reach the break-even point. Does the payback rule account for time value of money? The answer is again no. Does it account for the risk of the cash flows? No, you're just using the same cutoff point for every project. And does it provide an indication about the increase in the value of the firm? Again, no, because it is asking the wrong question. What you find is, how long does it take for the project to recover the cost? It doesn't have any indication of whether you're adding value to the shareholders or not. Should we consider it as our primary decision rule? Probably not. It's not going to be a very effective analysis if you use payback period for your project. But I want to qualify that with the next slide. In real life, payback period is one of the most popular methods used by the firms. And the reason is that even in the most sophisticated multinational corporation, they are making thousands of investment decisions on a daily basis. And not all of those decisions warrant a detailed analysis, because the cost of the analysis would be more than the possible loss from a mistake. So as a practical matter, an investment that pays back rapidly and has benefits beyond the cutoff point probably has a positive NPV too. So what happens is that in a given corporation, hundreds of small investment decisions are made every day. And as a result, it is not uncommon for them to require, for example, a 2-year payback period for all investments of less than $10,000 or $15,000. Investments larger than that may require a more detailed analysis. Okay? So I hope you find this video useful, and thanks for watching.